Hey, Algebra 2. Today we're going to do 7.1 Sequences and Series Definition. Today we're going to focus on what a series is. So what is a series? First off, right here I have an equation for my sequence. So let's say if I want to find the first four terms, I plug in 1 into here. 3 times 1 is 3, plus 1 is 4. And then plug in 2. 2 times 3 is 6, plus 1 is 7. 3 times 3 is 9, plus 1 is 10. And then 4 times 3 is 12, plus 1 is 13. So all I do is just plug it into n, right? If I asked you, please give me the first four terms of this sequence, this would be 4, 7, 10, 13. Okay? Pretty straightforward. That's something old. That's what we did last time. But now we're going to apply it to series. So what does the series mean? Well, if I asked you, how can I get, I'll ask you, can I get the sum of the first four terms of this sequence? Now, if I wrote that out, that's really long. So we're going to show you what is called sigma notation. It looks weird, but it's kind of very straightforward. So let's look at what it is. We're going to first draw the sigma symbol, which is a Greek letter that looks like this. Probably, let me make it a little bit nicer. It's like flat on the top, okay? So we have a sigma symbol just like that. Now the top and the bottom is going to represent where I start and where I finish. So for example, down here, I'm going to start at n equals 1 on my first step. I'm going to end at step 4, so I put 4 on top. So what this says, I want the sum from steps 1 to 4 of the equation that's going to be right next to me, which is 3n plus 1. This right here on the left is sigma notation. This right here is sigma notation. You want from 1 to 4, add up all these things. So what this tells me is I want to figure out what are the terms from 1 to 4 and add them all up. We already figured out the terms, so let's just add them all up. So we have 4 plus 7 plus 10 plus 13. That's from 1, 2, 3, and 4. Add it all together. This is a 20, this is a 14, so we got a 34 in total. So we could say the sum of the series 3n plus 1 from 1 to 4 equals 34. Okay? So I'm going to erase this, and then we're going to do an example. All right, I put 2 examples here. I might do one more if I think about it. But let's talk about the top one. So I want from steps 3 to 5 to find the sum of this sequence 8i. So it could be any variable. Since it was I here, I match an I here. If it was I here, I match it here. If it was an N, it'll be an N. If it was an X, it's an X. If it's a Q, it's a Q. Doesn't really matter. So this top one, from 3 to 5, from step 3 to step 5, I want to find the sum. So what does that mean? Do I need step 1 or step 2? No, I do not need step 1 or step 2. I'm starting at step 3. So I'm going to do 3, 4, and 5. Now let me move this into the camera's view. So I got 3, 4, and 5. So now let's see what each value at this equation is at 3 and at 4 and at 5. Well, 8 times 3, 8, 16, 24. 8 times 4, 8, 16, 24, 32. And 8 times 5 is half of it times 10, which is 40. So from there, we want to add all these bottom parts together. So we have 24 plus 32 plus 40. And that's going to be, that's 6 in the ones digit, and then 4 plus 3 plus 2 is 9. So our answer for this one is 96. Okay? Let's go on to the next one down here. From the values of 1 through 10, this equation is 2. Now you're looking at it and you're going to be like, wait a second, Mr. Tobel, there's no variable n in here. And you're right, there is no variable n. So what does that mean? Well, at step 1, 2, 3, 4, and 5, I plug in the n, but there is no n to plug in. So at step 1, it's 2. At step 2, it's 2. At step 3, it's 2. Step 4, it's 2. Step 5 is 2. 6, 7, 8, 9, 10. Step 6 is 2. Step 7 is 2. Step 8 is 2. Step 9 is 2. Step 10 is 2. Because there's no variable here, it never changed. It's a constant. That's why we call the numbers by themselves constant, because it doesn't change. It doesn't matter if this is a billion or 1. It will always stay 2. So we still add them all up. So you got 2 plus 2 plus 2 plus 2 plus 2 to blah, 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 blah. There's 10 2's. So to add 10 2's very quickly, we should use multiplication. So 2 times 10, this should end up equaling 20. Right? Because you're adding 2 10's. When you add things multiple times, we multiply them. So 2 equals 20. Or this sigma, from 1 to 10, the sum of the sequence of 2 is 20. Right? Let me pick one more, and then I'll call it the end of the video. All right, let's finish off with this example. This one, notice the variable is in the exponent, and that's okay. So I want the sum from 1 to 4 for this equation 3 to the n power. So I want to figure out my parts at 1, 2, 3, and 4. So I plug in a 1 into here. 3 to the 1 power is 3. And I'm going to plug in a 2. 3 to the second power is 3 times 3, which is 9. 3 to the third power is 3 times 3 times 3, which is 27. And 3 to the fourth power is 3 times 3 times 3 times 3, which is 81. From that point, I just want to add all the pieces together. See, 9 plus 81 is 90, and then 27 plus 3 is 30. So 90 plus 30 is 120. So your answer for this one is simply 120. Okay, so in this section, I would say make sure you have your calculator handy, because it'll make your life easier when you have to multiply or do weird things. But otherwise, it's straightforward. We just plug it in, and then we add it all together. That is what a series is. It's just adding a sequence all together.